So this is sort of about a journey. McKinstry, we're headquartered in the northwest of the United States. We were founded in 1960, and we've always had a little bit of an innovation bent, partly because the founder of the company was a professional engineer, which was kind of unusual in 1960 for contracting. One thing that's, I think, always interesting for us is to often end with photos like this. You know, our roots are really in the craftsmanship of all that we do in the built environment, and so we often like to think about the trades and how they help us along. So I got to McKinstry in 1978, and so then we had become, obviously, started as a plumbing and piping contractor, added sheet metal, and we're just on the verge of adding engineering. And we've done sort of all these internal lines of business adds, often by hiring a salesperson, a superintendent, an estimator, and getting into a new line of contracting. Over the years, some have gone well and not so well. But today what I want to focus on is the last batch of businesses or lines of business that we have started, all generally coming from a development project that we worked on. So this is my family, and in 2007 we went to Machu Picchu, and so we were hiking up to Sungate, which is at a pass with more ruins, and looking back here at the ruins of Machu Picchu, and then also at Huayna Picchu, that peak. And so as a family, we knew that we could go climb that. It was part of the admission to the site. But, we were like, oh, man, we couldn't do that, or could we do that, or I don't know. Well, we better decide, because 15 minutes from now they cut off the line because everybody has to get through by 3:30 to start climbing. So we hustled back and we said, yeah, let's go try it. Let's at least see if we can get through and into the line. And so we did, and then we climbed it. And as parents, if we had known what we were getting into, we never would have done it. And in the United States, I guarantee you could not do this. Once in a while, there was a cable, but a lot of the area, you could fall 300 or 400 meters with one stumble and take people with you. So this was really an interesting climb. But the idea was we were there, we were on the journey. We hadn't set out to do this, but when you're on a journey and you see opportunities, sometimes we say no, sometimes we say yes. And today I want to talk about where we were on a journey on this project and we just sort of kept saying yes, and we'll see how that journey goes. So this is the South Landing development, which I'll talk about today. So this is in Spokane, Washington, northwest of the United States, in Washington State. And let's see, is there no pointer on this? Oops, let's go back. There we go. So to the right of the slide is a university district. Gonzaga University is by far the largest university there. But 4 other universities have co-located in that same area. And that's why it's a university district. And one of the reasons that they are co-located is primarily to share and work on healthcare collaboratively together. The city built that Gateway Bridge. It was called the Bridge to Nowhere because the university district master plan actually goes all the way to where the healthcare facilities are on the left of the slide. But they've never been able to jump across the railroad tracks. And so the South Landing site is really the beginning of this university district expansion. So Avista Utilities is the gas and electric utility in this area. We had been working with them for 15 years or so doing energy efficiency work in their buildings, sometimes repositioning buildings, sometimes just basic MEP contracting. And they owned the property at the foot of what was going to be this bridge, and that's why it was called the landing, or the South Landing of the University District. And Avista, the CEO, had this idea that, hey, as a good corporate citizen, we're not going to put a substation on the property, which was the plan. We're going to make this property available for development, and that they would contribute the property. So they started looking for developers, and we, an MEP contractor, energy efficiency company, we'd done a little bit of development for ourselves, the facilities we sort of live and work in. And they couldn't get a developer to kind of follow their lead, and so we said, we'll do it for you. So the idea was to do this one building. Avista had this idea that this property would be part of what could be called the 5 smartest blocks in America. That was just a dream for the utility. Nobody knew what that meant, but it was a vision. And this site could have 3 additional buildings in the future. So the first thing we did was we formed a development company. So now we're starting our journey. And we thought about this as an innovation journey, and that us as a development company, we have no intention of competing with the developers that we worked for day in and day out, but this was just a little boutique operation to try to do something special on a project. So, what we got the chance to do was, we have always been in, thousands of these projects, and some take your ideas or other team members' ideas, and often they don't get taken in total, or often they don't get studied. The idea stops at a comment, and nobody will really say, well, let's really study that and look hard at the idea. So we said, we want to change the budget as the developer and include some innovation budget so we have money to spend. And as a developer, we don't want to lose control of the energy spent on the project. In the States, often we have projects where it's a triple net lease and the tenant pays the utility bill, and the developer, the real estate holder or owner, has no incentive to save energy, because if the developer spends $1 million on the project to save energy, all the energy savings just go to the tenant, and the developer doesn't have a return on that capital. So we said, we're going to work on that. So the first thing we did was, in the pro forma, we just set aside $2.6 million. We created some buckets. We had no idea where the money would be spent or how it would be spent. It was really just some line items to create the bucket. And then we said, okay, how are we going to retain this incentive as a developer to work on lowering the energy use? And so we did a type of a green lease. The anchor tenant was a university, Eastern Washington University, and in that market, it was going to be about $1.50 US a square foot for utilities annually. And the university said, gosh, that's great, because we're in a bunch of old buildings, and we spent a lot more than that. We're happy to get in this building and spend that money. And we said, well, rather than have you have your allocation at the end of the year, how about if we fix that spend, put it in the lease, and you just pay us that amount every year? And the incentive for you to do that is we'll put a real low inflation rate on that for the life of your lease. And they said, fine. And we said, the reason is, we want to go to work lowering the energy spend on the building, and this will be a way that we get the incentive to do that. Another issue is we often get into these contracts where, we're working on the shell and core, but then we don't work on the TI, or we work on the TI, or we work on the design of one or the other, but that gets broken up by contracts, because often the tenant gets to control their design and build in the lease. So we said, as a landlord, since we're writing the rules, we're going to retain control of who we hire for tenant work and to deliver the project. And with the tenant, the anchor tenant, they were thrilled that we would hire their designer and work on their program with them, and that we would do it turnkey design build, and even to the point they allowed us to have their FF&E budget, which we asked them if we could, so that we could have all of the digital work in the building all under our control. So we looked at the economics. If we could get to a zero energy building, we really didn't set out to go there, but if we could save that $1.50 a square foot, if we used a cap rate, that $1.50 a square foot would increase the cash flow on the building to the investors. That would be worth about $3 million increased asset value on a cash flow basis. And if we could do it, the utility said, hey, we'll give you $1 million of rebate. So the idea of zero energy was worth $4 million to the asset, and we said, well, we know we want to chase low energy, so let's take $3 million of that and we'll add it to the budget. So we ended up with the 2.6 plus $3 million, $5.65 million that we put into our construction budget, design and construction, and that's almost 10% of the project construction budget. So this was a significant amount of money that we had to spend. So the design proceeds. So we started with a steel and concrete building, 129,000 square feet. Early on, we knew we were going to look at CLT. We had been working with Katerra. We were building their factory. We did a lot of work for them in the Northwest. And so we decided to go CLT, and it worked out great for us. We could be one of the few companies that had a good relationship with Katerra, and they delivered for us. When it came to the building envelope, we were thinking about lowering the energy spend, and so after a lot of study, we decided to go with a passive house envelope. And then we looked at a lot of other ideas for energy efficiency, certainly PV. And then as the project progressed on paper, the anchor tenant wanted more space. They started with putting their computer science and electrical engineering programs in the building. They added a physical therapy and some other cybersecurity and so on. And so we carved out another half floor. This location of this project is a basalt lava flow, and so we spent about $1 million blasting rock to create more space. And the central plant will become part of the story of we didn't have a place to put it because we were on rock. But the roof was as much PV as we could have, plus some other buildings, and we ended up with an energy use intensity number of 26. We were targeting about 20 if it had been office and friendly tenants to low energy use for an office environment, but the university with classrooms and AV, that brought the energy use up on the building. So on the journey, we got to this point and we said, hey, let's take the risk and let's go zero energy for the building. And so we made that choice. And then we broke ground. I put this slide in here because who else but a mechanical electrical contractor would build shovels like this for the groundbreaking? So that's a 3-foot pipe wrench, and then we cut the shovel head with a laser cutter in our shop. And that's our idea of what a groundbreaking should look like. So now that we're zero energy and we've broken ground, now a lot more engineering work comes in, of course, and now we had some budget to really pay our design team to go to work with studies. And so this is just a snapshot of what the annual energy profile would look like on a plant, on the central plant. But we said, hey, with utilities our partner, the world is headed to zero carbon. What would be the implications if we said zero carbon energy for this building? And that meant getting rid of all fossil fuel, and there was going to be a small restaurant and a little coffee shop. But certainly it was about the gas boiler or boilers. And so we said, well, let's go zero energy or zero carbon. And so we switched to electric boilers. And that on a cost basis is not so bad until you add in the electric service. And so now we had to be really careful about the design because we wanted to control how big the electrical service got on the plant. So we built a parametric model, and this took several engineers and estimators a month to build this model. And so the headings over there are ground source, heat pump, heat recovery chiller, air source heat pump, hot water storage, chilled water storage, the cutoff temperature for the air source heat pump, which was a variable, total EUI for the building, and then first cost of the plant. And so the reason that we spent all this time was one of these ideas that we always wish we could do on the projects that we're involved in as a contractor, where we could really optimize in a total cost of ownership view the plant. And so here in this run, we've said, okay, we want to live within this band of energy use. And then we said, okay, what's the lowest cost plant configuration that keeps us in that energy use? And here just shows 3 examples. But this was a huge payoff, big investment, but maybe probably a 10 or 20-fold payoff in terms of the cost to do this study, in terms of, we maybe would not really have known where to size the equipment, and we would have guessed conservatively, and we would have had a much more expensive plant. So as I mentioned, we were on this lava flow, and we didn't have enough head height in the basement, the daylight basement of the building we were building, to put a plant. So building A was the first building, and there was a future building, and so we said, well, we want a central plant. We're not going to go backwards on the kind of equipment, so let's build the next building. So on this journey, zero energy becomes zero carbon. Now we're getting another building. Now we have a whole lot more unleased space as a developer that we have to take care of just to get a space for a plant. This started as a 2-story building, but that didn't pencil as a standalone building, so we made it a 4-story building. And the MEP contractor is not going to hide a plant, so we put it on storefront to show off the work. And also, this idea that, this is a student campus, and it's a public-private partnership in terms of not only university occupancies, but there'll be a lot of people in this neighborhood. And so we wanted a way to highlight this and what it meant to this development. So the idea is that this plant would serve the first building as it was intended. We're going to serve a second building, why not? And then we've got 2 future buildings. And so we said, well, what's some more risk we can take? Well, let's expand the footprint of the space for the plant so that we can add more equipment in the future. Let's add all the headers, do all the design now, run the pipe underground because we didn't want to cut the ground up later. And so we really turned the plant into an energy district or an eco district. So it's a neighborhood energy district. And with the utility, who's a real progressive utility in our area, they said, hey, we're really interested now in this eco district. We would like to somehow be involved so that we can understand how this works, because as loads shift for them, in some cases demand goes down, district energy is coming more into play, and they thought maybe in the future they would be building district energy plants. And so we said, well, we can take that plant and we can pull it out of the development, make it a separate entity, and would you like to invest in just the plant? And they said yes. And so we made a separate entity of the plant and created a partner at the same time. So the eco district, started with heating and cooling, but then we certainly wanted to think about thermal storage, but just from an energy use point of view, when we can capture both heating and cooling at the same time. We ran all of the electric distribution. This was the utilities idea, an experiment. We ran all of the electric service through that plant to serve the 4 buildings, which is really unique in a private development with separate parcels, and I would not recommend it. And I mean, that was an experiment that was done, and it did not pay off well. But here you see this the LED screen there. We wanted to activate this space so that students and the public walking by could see how the plant operated, what it was intended to do, and have a way to engage the public, and so that's what that is. We certainly started on the left, a typical building, but we didn't want to end up there. We made the building more energy efficient. We ended up with a zero energy building in design and starting to be delivered. And so this is what happens to the daily load profile for buildings that have PV or a way to lower the load significantly during the day. And utilities, this is not their friend. They're already having lots of problems with the variability on the load with renewable energy. And so what they would like most is to have a predictable building. Now that doesn't mean that the load doesn't change during the day, but they have all kinds of data off of their substations of how they act based on temperature and what day of the week and so on. And when you put these zero energy buildings on, it's a whole new game for them with their substations. So now the utilities are our partner in the plant. We start talking about this grid integrated building as really what they would like. And so we said, okay, well, let's have that become now part of the charter of this project. And so, the 2-building complex now has all of these features that we had programmed and designed in. We increased the thermal storage to give it more decoupling from the grid, and we added battery storage as another way to further decouple the buildings from instantaneously load to the grid. So, building automations systems today are, extremely complex, potentially. They certainly can handle all the sophistication needed for these kinds of activities at the site. But now we're going to add, grid signals and inputs from the utility and try to create algorithms at the utility and here to serve these buildings and so on. And so, now we're getting into a game that is a lot more complex. And so we formed another company called Edo, and this was to go beyond the building automation system and be able to work on algorithms and do some machine learning and really sit between a project and the grid on behalf of a utility so that, Edo partners with a local utility to provide these services. And the utility said, ooh, that's a game we want to be in. So they invested in that company too. So, there's a lot of data moving. It's all around getting to actionable data, and we're in this transition. There is not yet an autonomous smart building, and so the human interaction in this is still extremely important. And so we're doing a lot of data collection, a lot of machine learning, just now starting some AI, but the human is still really an important part of this. And so, but it is us taking a step toward this idea of an autonomous smart building. So here are the completed buildings. I guess I'm not sure the pointer. Our offices are between the two blue stripes up there, so in the distance. So that's one of the reasons we actually live and work in this university district in this city, and so we have a real vested interest in this community. So back to this topic of tenant work and how it could provide some innovation. As an MEP contractor in our neck of the woods, a lot of architects are leaving ceilings out. I don't know about here, and they like the industrial chic. And so, we love doing this kind of work where you look up and get to see what we do. And our cost goes up when ceilings are eliminated because now the architect plays with, I want you to change the finishes. I want you to move this. I want you to move that. It's got to look a little more clean and crisp. And so we knew in our building that we were not going to have ceilings. And so now we're worried about controlling the budget as well as the look. And so, this is our building. And so, one unique aspect of this building relative to CLT, we have CLT exterior walls. So that was a Katera idea they wanted to bring to the project. And so we thought, well, what if we, since we're in control of hiring the architects and having a design standard for the building, what if we talk the architect into using acoustic clouds as an organizing element so that we could land our MEP and data devices on these clouds or near them, and then it would give us a way to organize our small bore pipe and wire. So since we got to sort of call the shots, so we did that. So these are an early iteration of these ceiling clouds. And you can see, the types of devices. This was ended up being really beneficial for us as the contractor, but ending up as the landlord to have this way to think about what we were going to see when we look up and not just have what can happen on a project, even though we would try to control our own work, that it might look a little unorganized. So as we're building mock-ups and we've got architects involved, and we've got critical friends in the industry, and we said, hey, we're working on this idea. they said, well, gosh, we've got a project over there, we don't, and we didn't even know yet how this penciled. But we said, hey, we could offer these to others on a real select basis, but we're not really geared up for that. But it got us to think about, okay, well, what are all the technology systems that would be either attached to or related to the ceiling cloud? What we were calling these splines for small bore pipe and wire. Oops. And then we thought about, if we're going to talk to others, let's try to let's ask and answer a lot of questions we know are going to come up. So the form factors, the different finish options, they're going to ask us, how does it look in our space? So what's the software that we can offer to, do some visualization? Photometrics, our electrical design team it does this kind of work, but we thought we might need to bring it in as part of the cloud solution to show an architect, so at the same time, you could have the photometric analysis. Certainly acoustics became part of an issue. We did shake table tests for structural analysis, and then, what are all of the types of lighting and HVAC devices? And then we're just about here to be able to have a red list-free product as well. So as we're on this journey and we're delivering this project and we're talking about, other potential jobs, if we start to offer this to others, what are our learnings on the project that we are building? And so, we're starting to get some OEM relationships. So rather than getting the lighting through a lighting distributor through our own electrical contracting company and then shipping it, to our factory to sort of provided by the contractor to install at the factory on these devices, we said, well, let's just, as a cloud manufacturer, let's get our own relationships. And so we started to line up several relationships, and we got to see how much we all spend in the distribution and rep and other markups along the way. And so there's actually a lot of money you can save by changing the supply chain. And then we started studying our own critical path on the project, and with our own electrical contracting team and mechanical team and so on, and data, with the work done off-site on these clouds, and even manufacturing a lot of the low voltage and small bore pipe and wire off-site. What happens, how much work did you take off-site, and what did that do to the critical path? And there's a lot of overhead work and a lot of different people on ladders, and so it's quite a benefit to move this work off-site. And then the logistics, certainly, these are big boxes and so on, but you get these in, they can go up maybe next day, recycle all the cardboard materials and whatever, so the logistics is pretty easy to understand. And then for commissioning, and certainly O&M and operations, a QR tag on there and all the commissioning data, you pre-commission these at the factory, and then certainly final commission at the site. But also part of this was the idea that, make it easy for warranty, or add a device, take a device off as tenant work happens for the life of the building. And then certainly the idea that you could reuse and reconfigure these, which is the way that buildings ought to be built. So that certainly is part of its future. So this company we call Overcast Innovations. And it really is working on this idea now of a smart ceiling. No longer, you can think of the ceiling as a system in its own right, as opposed to trying to have the smarts overhead, try to think of it as a connected system. We thought originally, well, this is a no ceilings kind of a product, and then the architects said, well, why can't I just put them in the middle of a ceiling? And so this was an early iteration. Yes, you can. And at that point, it was, well, you're going to see it below the ceiling. And then as we move along, well, certainly you don't need to. You can integrate it better with the ceiling. And then certainly you can have highlighted spaces where it's a feature. We're getting a lot of traction in sort of the R&D and medical and healthcare because of the utility panel that you can integrate. And as we are now talking to developers of these kind of buildings, that's one of their biggest pain points with the tenant work, is having an organized way to get these utility connections. So a recap of this journey. So, we started with a budget from the utility that says, here's steel and concrete pro forma that we got from a couple of developers. We're all in. What can we do with that? And we started working it. So early, we went to CLT, and then we said passive house. And this was, the whole idea was, each step along the way, now we're looking at something and we're going to go left or right. But this project didn't at all start with where we ended. Then we added an eco-district. We're certainly zero energy. Now we have to have a lease that supports this. We went zero carbon in addition. Now what about this building as battery, a grid-integrated building? And then the utility said, okay, now we're all in. We want to learn. We want to be in the eco-district. Let's increase the thermal storage. And we added this electric eco-district. That's a story and a half. Added battery storage. And it was network operations center. Now we have to have a way to operate this building cooperatively with the grid and the utility. That's EDO. And early, as this was forming up with all these ideas, one, we were testing these ideas with national labs in the US and so on, because they have a lot of great research, and they've studied lots of these kinds of ideas 10 and 20 years ago. They just haven't had an implementation path. And so we were getting a lot of interest, and there was getting a little buzz in the industry of, wow, we need to go look at this project. And so we had people seeking us out to become part of the R&D on the project. And so we have ended up now with these buildings and as a living lab. There are universities doing ongoing research, the PNNL is doing ongoing research, and so on. To the point that we have won some grants. We're, I think, over $7 or $8 million now of grants from Department of Energy to involve these two properties in a neighborhood research in terms of load management across about, I think it's 500 buildings that we're working with the utility. And then this idea of, the tenant work, how important that can be either to the project or to those that work on the TI. For us, it was getting the exposed MVP organized. Out of that became the clouds. As I mentioned earlier, we had kept all of the low voltage systems in the building as a developer. And, we're an MVP contractor, and we do a lot of low voltage and wireless work. And so we handed that whole bundle to our team, and under one single team, they delivered all low voltage systems in the building. And so that's that integrated approach. Then we launched Overcast Innovations, and South Landing was the pilot for that. But then we said, hey, let's do a market launch, and we'll offer that to others. And so these green items are for us either now a new company or a new offering that, for the most part, would not be where they are today and out exposed to the market and getting revenue for us had it not been for us doing this project and trying to take the project and see where we could take it along these ideas. And COVID was mentioned earlier. So these buildings opened September of 2020. And so when the lockdown happened for us, which was March of 2020, we're coming in the home stretch to deliver these buildings. And so for us, it was somewhat of a heroic effort for everybody involved to get these buildings open on time. And we did it on budget with a market rate return. And so that's a whole, one of the goals of real estate development certainly is developers would want to do many of these kinds of ideas, but the budgets don't work out. And so often the projects get cut short of going where they could go. And so, we were able to do it with a market rate return, and part of that is maybe Katerra taking the job a little too cheap as a demonstration project. So in hindsight, we think about this, take risks, involve others, think bigger, create a legacy. In every project that any one of us would do, why wouldn't we think about them this way? And this project for us was a real demonstration of how that can all come together. So that is the end of my presentation.